Hello everyone! For this tutorial video, I'd like to demonstrate how to work with irregular polyhedrons, which, similar to the problem with regular versus irregular polygons, has an extremely broad, nearly infinite, amount of shapes covered by this definition. But since we proved that we could break down complex regular polyhedrons into simpler ones, it should follow we can do the same thing for irregular ones. In particular, if you were to study something like the table I'm using to lecture right now, which has no curved surfaces, and so therefore would be an irregular polyhedron, we can see that the legs would count as rectangular prisms, and the platform I am using to teach would also be a rectangular prism. And there would also be rectangular prisms for the platforms that are used to contain the papers or other objects you wish to set aside. And technically, the container platforms would be made out of two rectangular prisms rather than one, because there is a second one that serves as a sort of wall. And similarly, the top platform would be two rather than one, owing to the smaller prism beneath the topmost platform that is used as a sort of support. So we can see that the overall volume in the surface area of the object would be a sum of the surface area and volume of these individual objects, although we must remember that for surface area, the total sum is not the whole answer, because, for example, the surface area at the bottom of the topmost platform is not a full rectangle, owing to the parts occupied by the support beneath it and the legs. And by similar reasoning, the surface area of the legs would not be the total rectangular prism, because the topmost surface of all the legs are joined to the topmost platform, and so therefore would have to be subtracted because they are no longer on the surface of the total object. Now that I've explained how to break down any flat-sided 3D object into simpler ones, I can start teaching curved 3D objects, starting with the most basic type, the cylinder, which is analogous to the prism, except the bases are circles, and the height is now a smooth, wrapped around curve, rather than something that can be broken down into a countable number of rectangles. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.